Hello, everyone. Welcome to this session. In this lecture and the next one, we're going to talk about cybersecurity. So if we want to briefly say what is the content of this lecture, it is that we're going to talk about mostly about the attacks and hackers and threats mostly. And in the next lecture, we will talk about the solutions that exist for them. So to start this lecture, I would like to just briefly introduce the meaning of cyber. So you might have heard the word cyber often, like cybercrime, cybersecurity, cyber attack, etc. So cyber means something related to information technology, for example, computers or computer networks. So a cyber attack is an attack that is related to information technology or computers. So in this lecture, we will talk about attacks, cyber attacks and hackers, their motivations, and then what does cybersecurity means? What are different attacks? What are different threats? What is the definition of attack vector? And what are different aspects of security in the cybersecurity industry? So, we are always connected through the internet via our phones or our computer or even our household devices. When we are connected, then there is a possibility that attacks can happen from different corners. What if someone gains control of your computer or your phone, or someone just gets access to one of your personal accounts? All these are called digital attacks or cyber attacks. And so to be more specific, a cyber attack is an offensive behavior that targets a computer, information systems, computer networks, infrastructures, or personal computer and mobile phones. And the attacks can have different effects. For example, they can breach the personal information of the people, for the sensitive information, for example, the credit card information or passwords, etc. Or they can even be worse, meaning that expose governmental sensitive data. So then what is cybersecurity? Cybersecurity is a set of techniques for protecting the systems, computers, networks, or even programs from digital attacks and cyber attacks. And cybersecurity's goal is to protect the security, integrity, and availability of computer systems and the data which is inside them. So we will talk about integrity, availability, these terms more in the next lecture, but to give you an idea, these mean that the data on your computer or your computer itself needs to be safe so that you can always access your data. You must be sure that your data is not changed without your permission, and that no one without the right permission gets access to your data and sees your data. So this will be talked about more in the next lecture, but these are what cybersecurity is concerned about. So who are hackers? Hackers are those who try to break into computer systems and perform cyber attacks on individual computers or computers in a company or even government resources, for example, servers, computers, etc. There are usually two main categories of attackers. The first one are called white hat attackers. They are those who are good guys. They hunt for bugs and try to close security holes in a software, and they want to actually make the software better. So you see, for example, when you install a software on your computer, there is often that you receive later on security patches. These are, so there were some security issues that were discovered, for example, maybe by white hat attackers, and then they try to solve those security issues and give you patches to install. So these are good guys. But on the other hand, we have black hat attackers or hackers who are malicious hackers who really have bad intentions and try to steal your information, exploit your information, or try to find a computer's vulnerabilities, meaning that security holes, for example, and use that to get access to the computer and the data that is inside. So attackers, as we have seen in these two main categories, seem to have different motivations. So it is interesting to know that most of the attackers actually are not bad people. They just mostly want to get access to other computers for fun or thrill. So they just want to do it as a kind of hobby, maybe. But there are other ones who want to gain money. There are a few ones that participate in. Actually, there are some competitions and there are awards for hackers to find, for example, security issues in very important systems, because then they want to make their system even more secure. So they set awards for those who can find vulnerabilities, or there are competitions just to uh, improve the competencies of people. And there are some attackers who have bad intentions. They are moral issues. They just want to ruin a system and get access to the data and do something not good with it. So we have seen so far that we could have different attackers with different motivations, so they might use different ways to get into the computers. So then we have the notion of attack vector or threat vector, which is a means by which an attacker or hacker can gain access to a computer or network server in order to, for example, get access to data, or maybe even run a program there, install a program there, or do many different sorts of things. So here you see several examples. We will talk about this more, that how they can get access to a computer. For example, they might get access to passwords when we have weak passwords, or they might trick us by phishing or by bad software, or they might attack a system using DDoS attacks and so on. We will discuss about some of this in the coming slides. So when we have attackers who have their own attack vector and they have their own motivations, now there is a question that what we need to do and how we should do that. So then there is a notion of threat intelligence, which is the continuous gathering of data of possible attacks. So in order to have a secure system, we need to have threat intelligence. We need to gather continuously data about the possible attacks that might happen, because we need to then think about the motivations of attackers and their attacks, and we need to think in advance before the attacks happen, that what would be the scale of an attack, or what threat vectors an attacker might use. So we need to think about our system thoroughly and see what are its weaknesses and how attackers might misuse them, for example. So then having threat intelligence, for example, in a company or in a system, needs to use different professionals from different areas. For example, it needs to use data scientists and those who are expert in machine learning, because there are a lot of data related to a computer that need to be analyzed to realize what are the, for example, what could be the scale of the attacks, or what could be the threat vectors that an attacker can use. So then all this information needs to be analyzed with machine learning and data science. So attackers can have different methods to attack a system. here we want to talk about some of the most famous and mostly used ones. For example, an attacker might do password attacks, meaning that it might try to gain access to your password. We will talk about all these in the coming slides. They might try to use a malware to get access to your computer, or they might use social engineering to trick people to give them data they need to break into a computer. Or they might do man-in-the-middle attack, or they might do DOS or DDoS attacks. So let's see what they mean. Password attacks are simply some attacks in which a hacker tries to crack the passwords or pins of people to get access to their personal information. So there are different password attacks that can be done. The simplest one is called the brute force attack, in which a hacker tries simply blindly all possibilities of, for example, a PIN code. Imagine you have a PIN code with 4 digits, then you have to try any number from 0000 to 99999. For human beings, it is very difficult or time consuming, but for computers, it is very easy to have a for loop with a simple counter and just try all possibilities, and they are very fast. So this is not a clever method, but usually the computer systems are smart now, so they don't allow you to try any number of passwords or pins that you want. Usually they try to block you or don't let you try new things, at least for a limited time, if they see that you are trying passwords that are failing. But hackers, get smarter during time. So what they do when they want to do password attacks is sometimes that they use other computers, a network of computers that each of them does a portion of the attack. So each of them tries some different passwords. So all of them at the same time have just a small number of passwords to check. So then the computer that is being attacked will not realize maybe that it is a single hacker that is using all those computers. So then in this case, maybe a hacker can be able to find the password. So then for this reason, PIN codes that have only numbers in them and are short, for example, 4 digits or even maybe 8 digits, are not safe, so they can be easily checked by a computer or several computers, because the different cases that they have to check are not too many for a computer. So in case of 8-bit pins, we have 100 million combinations roughly that can be easily divided between several computers, and then they try to do it, and then maybe they wait for a little before trying many. So instead of trying many different passwords at the same time, maybe they wait a little bit so that the computer that is being attacked doesn't get suspicious. So this was for brute force attack, in which it blindly tries to find the password. And for there are other smarter attacks. For example, another one is called the dictionary attacks, which is used for passwords, not PIN codes. In passwords, dictionary attacks is performed in a way that all the vocabulary inside the dictionary, for example, English dictionary, are tried, because it is very common that people just choose meaningful words. So then attacker tries to see if one of them can be the password. So for this reason, we need to have stronger passwords. For example, we need to mix in our passwords numbers, punctuation marks, alphabetical letters, and both lowercase letters and capital letters. All these makes our password stronger, because all the possibilities that an attacker needs to check are much bigger. So an attacker cannot simply use dictionary attacks in this case, because there might be other characters in our password other than the words in the dictionary. So then this becomes more difficult to crack. So for example, if in our passwords we have 3 words, then the state space, meaning all the different cases an attacker has to check, is quite big. It is 1 quadrillion possible passwords. So these passwords are actually very difficult to crack, and they are easy to remember. So imagine your password simply has 3 words. For example, I ate breakfast. Because it is using 3 different words, and in an English dictionary we have like 100,000 words, then you see the state space becomes huge. So now let's talk about malware. A malware is a malicious hardware or software which is inserted into a system to damage that system, or to gain access to that system, or to gain access to a network. Any type of malware can greatly compromise the security principles, for example, being confidentiality, integrity, or availability. These 3 terms, being confidentiality, integrity, and availability, will be discussed much more in the next lecture. But as I said briefly, they talk about that the concepts that you need for security, being that you don't want that unauthorized people get access to your data, you don't want that unauthorized people change your data, and you don't want your system to stop functioning. The last one is actually called availability, meaning that you want your system to be always available. For example, the server that you want to work with, or your computer, and so on. So a malware is a hardware or software that tries to breach these security principles in your system. A malware can have many different forms. So for example, some steal data from your computer, and some others try to get your data out of your reach. For example, they hide your data. It is called encrypt. We will see more in the coming lecture what encryption means. Now let's think about it as hiding. They hide your data, and they ask you for money to give you back your data. So let's see what are different kinds of malware. The most famous one is called a virus. A virus is a program, so it's a software that can enter computers or IT systems in many different ways. And then they can cause effects that are different. For example, they must be just something annoying, a pop-up window that just pops up every time, and then you have to close it. This is just annoying. It doesn't harm maybe your computer, but they are those viruses that are highly destructive. They might make your computer go totally out of function. They might make that you lose all your data, and you need to sometimes install all the software from scratch on your computer. And sometimes the destruction is irreparable, unfortunately. And the viruses actually are called viruses because they spread like biological viruses. So they need a host file, for example, a Word document or an image, and they might need also a host program, for example, a PDF file splitter, or some, you have sometimes are offered to download freely some programs that might be interesting for you. And then those files can actually have viruses. So they are called host programs. And viruses need humans to send them through, for example, emails or messages or attachments to replicate. So they are, in this sense, maybe similar to viruses because they spread from by humans, actually. They need human role in spreading. There are another kind of malware which is also famous. It is called Trojan horses. Those are programs that look like harmless attachments. For example, they look like a photo, but they actually contain malware or a destructive program inside them. And a very common delivery mechanism for Trojan horses are emails. So it is why we need to be very careful about emails that we get from unknown resources, and we should not always download just the attachments or open the links, because they simply can lead to viruses installed on our computer, or Trojan horses get access to our computers. Another kind of malware is called ransomware, which locks your files and hides them, and demands payment for you to access them. And once you pay, it is not guaranteed that next time you can access them freely. Maybe you are asked for money. So now, after seeing several famous forms of malware, let's talk about social engineering. Social engineering means using psychological manipulation to trick users. This is very important. They trick people into making security mistakes or giving away sensitive information. So in this kind of attacks, what is very important and is crucial, it is that they rely on human error rather than vulnerabilities in software or operating systems. So for example, when we have some malware, maybe that malware is using some weakness in the software on our computer. But social engineering wants to trick people and use their vulnerabilities instead of computer vulnerabilities. So a person then can be manipulated into revealing confidential information, or, for example, revealing configuration of a computer network or a computer system so that it lets attackers to enter. For example, it tells them what is my IP, what is my router's IP, what is my username and password. They trick people to give this sensitive information. So let's see some instances of social engineering attacks. The first one, which is very famous, is called phishing. So it is its name is funny. It's like phishing, but it is misspelled. So it is one of the most popular social engineering attacks. And in this kind of attack, email and text messages are sent to people that create a sense of urgency and or curiosity or fear in victims. So they actually try to convince the person, the victim in this case, to reveal sensitive information, for example, reveal their username or password, or click on links to malicious websites, or open attachments that contain malware. So always when there is some malware sent to you by email or something, there is also social engineering besides it that convinces you to download that attachment or open that link. For example, they say they create a sense of hurry in you. For example, they say you have just 1 minute to, or no, 1 hour to use this special offer. Click on the link below, or things like that. So they make you to stop thinking and just do what they want. So other example is that, for example, you receive an email that alerts a policy violation, which requires your immediate action. For example, it says you need to immediately change your password. So usually think twice when you receive emails that need your immediate action. And they emphasize a lot that you don't have time and so on. So in many, many cases, there is something fishy going on. And then that email can have a link to an illegitimate website. And then you go there, maybe you see a login page and it requires maybe your credential as for one of your real accounts, for example, for Google or Facebook. And that page might look like actually the real Facebook web page. So always make sure to check the URL of the pages that you click on. They might have an appearance which is similar to legitimate websites, but they are actually illegitimate ones. We have other social engineering attacks. The other one we want to talk about here is called pretexting. In pretexting, an attacker usually starts by establishing trust with their victims. So they impersonate co-workers, police, bank, or tax officials, or other peoples who, have an authority to know things. Um, for example, they pretend to be your boss, and when your boss calls you, then of course, whatever information they want, you would give them. So the pretexter then asks questions that are required, for example, to confirm the victim's identity, and victims in this case are us who are lured by this kind of social engineering attack. And via this attack, they gather, for example, important personal information. For example, and they call you and they pretend that they are one of the co-workers and ask for the username and password for one of the servers, for example, in the company, or ask for some detail about the network configurations in the company, which is sensitive, for example, and you would not give it to other people. But once you think that there is someone in your company, even maybe from the security department, then it makes it even worse. So as soon as we rely on them, then we might give them all the information they need to, because usually people like to be nice, like to be cooperative. So once they see that their coworker is calling, they want to give them all the information that they think they have the right to know. Another kind of social engineering, which is also very used, is called baiting. So it uses a false promise to pick a victim's greed or curiosity. For example, it tries to lure users into a trap that steals their personal information, or lets their malware to get in the person's computer. An example can be that, for example, imagine sometime in the parking lot of your company, you find a flash drive which has a label on it that it belongs to the salary department. And it looks like that it has all the information about the salaries of the employees inside it and their personal information. Then one would actually be curious to use this flash and see what is inside it. So then as soon as they put the flash inside the computer, as soon as they connect it, then this flash might start installing a malware on the system, and then using that, it might steal many information, or it might damage the system and so on. Or another example can be some advertisements that lead to malicious sites and encourage users to download a malware-infected application, for example, free downloadable program, which people might be very interested in, or things like that. Another kind of social engineering attack technique is using scare words. So scare words try to deceive people to think that their system is infected with virus, for example, or some sort of malware. And they prompt the users, which are the victims in this case, to install the software that is offered to them. Then this software has no real benefit or is the malware itself. So it is the virus itself. That warning was just there to lure the people to install the malware. So now we are done with the social engineering attacks. We want to talk about another attack, which is called denial of service or DOS attack. DOS attack is an attack to usually an important computer, for example, to a server, and it aims to shut down that server or machine or that network and making it inaccessible to the users that want to use it. And this is done, for example, by flooding the target, which is in this case, this server or network, flooding it with high traffic and a lot of requests that it cannot handle. So it crashes or it just gets busy with those requests and cannot actually answer the real requests from the user. For example, it has happened a lot, and we hear in the news every now and then that some server, very important one, for example, was under attack and was down for several hours, several days. And in some cases, the reason is DOS attacks, or they are also called the DDoS attacks. So in this case, a victim is not a person. In the social engineering case, sometimes the humans are victims so that their personal computer, personal data is threatened. But in this case, an important computer, for example, an organization server, web servers of high profile or banking servers, etc., are under attack so that they cannot serve their real customers or users. They are instead made busy by useless requests. So the next attack we want to talk about is called man in the middle attack. We will actually talk about this attack again in the next lecture. So this is some sort of eavesdropping, which is happening in cyberspace. So an attacker tries to, in this case, change a connection and eavesdrop it by sitting in the middle of the connection. So instead of having this connection, which is showed by this blue arrow here, the attacker will try to establish a new connection, and it itself sits in the middle. And to this left-hand side computer, it pretends to be the second party, meaning that it pretends to be, for example, the server that this computer wants to talk about. And to the server, for example, or the second party, which is shown here on the right-hand side, it pretends to be the first party. So it plays the role of both parties, and it tries to gain information by sitting in the middle of the connection, and it tries to misuse the data which is exchanged. For example, sometimes it just copies the data for its use, or sometimes it even tries to change the data. Sometimes it tries to send data that the first one has not at all aimed to send, or sometimes it maybe even delete some of the data that this party or another one wants to send to the other party. So an attacker in this case pretends to be both participants, and as I said, they try to gain information and data. And then they can misuse this connection to, for example, even send malicious links or malware to the parties in this connection. So we have so far talked about attackers and what kind of different attacks they have. and they might use. They will not use all these attacks on a system. It varies from system to system, what kind of attacks they will use. So when we want to have a safe system, we need to analyze our system and have a threat model. Threat model is specification of who our enemy is, who our hacker and attacker can be. And it's at an abstract level. So in a threat model, we try to prepare against a specific threat rather than considering all the threats that our system might be exposed to. So for different threats that might be possible in our system, we need to have different threat models. In some systems, as I said, some threats are not at all applied because they are out of question, for example. And a security analyst needs to analyze the system and see what threats are possible, what attackers and enemies are possible for the system. So when we talk about cybersecurity, there are different forms of security that can be considered. The first one is called information security. So in information security, we are concerned about protecting data in any form from being accessed or modified or shared or deleted by the wrong people, by unauthorized people. For example, when you have sensitive information on your computer, you need to have information security for them. We have another form of security, which is called application security. Application security is the process of developing a safe and secure application. It tries to find ways to add security features to the application, to the computer program, and tries to prevent security vulnerabilities. So it is about developing a secure application, software, or program. And then we have also network security. So in network security, the experts are concerned about protecting the network and data which is inside the network from breaches and intrusions and other threats. So in this case, they need to check access control. Who are the people who can have access to this network? How should they deny access for other people? And they need to think about virus and antivirus software. They need to also have application security, and they need to have network analytics to analyze this network and its security and constantly work on it and find the threats in a network. So they need to check the security of, for example, servers, endpoints, wireless devices, Ethernet devices, etc. So they need to, for example, use firewalls, VPN, and etc. to protect a network. So in the cybersecurity industry, we have also different levels of security. And there is the notion of a cloud, which is introduced in recent years, and in this kind of technology, people or organizations store some of their data on other computers, other servers, which are called clouds. So when we have clouds, we need to have special security for them. Because those resources, the data that are stored on the cloud need to be protected. So there are professionals in this field, in the cloud security field, that they need to be familiar with security in this environment, and they need to implement security in this environment. They need to make sure that, for example, when a data is put into the cloud, it will not be accessed by unauthorized people. It will not be changed or deleted, and it will be delivered whenever the client that owns the data wants the data. There is also in the another notion called critical infrastructure security, which is introduced in cybersecurity industry, and it aims to defend physical systems that are becoming more digital networked. For example, the energy grids, the hospitals, the schools, water supply systems, electricity supply systems, they are getting more and more digital and networked. So in critical infrastructure security, the goal is to protect those systems from uh, cyber attacks and cyber crimes. And besides the cyber attacks, there are also natural disasters that might happen and might affect the network for that infrastructure. So then the professionals in this field need to think about those phenomenon as well to protect the system. When we think about the cybersecurity, we see that no system will ever be perfect. It is the same as systems in terms of other kind of security. So no system will ever be perfect. There is always a risk that the system might be under attack. So we need to manage the system to make the risk as small as possible. This is called risk management. But how is the risk managed? First, we need to identify the risks in the system. For example, software vulnerabilities in case of a software system, or uh, we need to identify the risks regarding the people that are working with the systems, because they might be subject to social engineering attacks. Then once we have identified, we need to monitor those risks and treat them. For example, come up with security patches for our system, or educate the people that work with our system to minimize the risk for social security attacks. And because there are always several risks, we need to prioritize and start with the most important one. And then when we treat them, we need to evaluate our work and analyze and see whether or not this has been helpful. And then we go back to the first step. So we need to identify other risks. So this is an ongoing process to have risk management. So in a system that we want to have cybersecurity, there are security operations that need to take place. So people who work in cybersecurity are responsible for implementing security principles and monitor for incidents that might happen, monitor for attacks, for example, and recover from those disasters. For example, when a system is under attack, of course, they need to be solved and the system has to be recovered. So people in this area work closely with everyone in the security field to detect the problem. There are many cases in which a system can be under attack, but it is not detected. For example, imagine in case of man-in-the-middle attack, someone might be eavesdropping, but it is not always easy to realize that actually. So the first step is to detect when an attack has taken place or something has gone wrong. Then the people in this area need to implement preventive measures against cyber attacks. So they need to think how they can prevent those problems that have not yet taken place, but they might, because there are some vulnerabilities. And they need to make sure that they are, for example, backups in case of an attack happens and the data, for example, is lost. So, for example, they need to keep backups of data in several places, several physical places, and they need to have backups maybe for their computational devices, computational servers, etc. And they need to track the changes to a system, because sometimes you make a change to a system to solve a security issue, but you introduce yet another security issue. So they need to always track changes to see what risks are added, what risks are removed from a system. And they need to have plans to recover from disasters whenever they happen. So they need to have plans in advance. When a disaster happens, they need to be very quick. It's not the time to just plan. It's too late to plan after a disaster has taken place. And all these steps that was mentioned before need to be documented in great detail, so that the organization policies are clear in case of, for example, how to recovery, how to backup data, etc. Thank you for your attention. In the next lecture, we'll still talk about cybersecurity, but we will talk more about how cybersecurity is implemented rather than the threats that we discussed a lot in this lecture.